Okay, good day. Welcome to the Desmos version of the examples from lesson number 15 for Math 130. So we are going to do the Desmos version of the normal CDF. Now for Desmos, you're not using just the normal CDF. You are actually going to use the normal distribution, so normal D-I-S-T, normal dist function. Now, one thing that Desmos does is it combines a number of functions together that are kind of in the same group, and normal CDF is a part of this normal distribution function. So here's what we're trying to do. If you listen to the first part of this lesson, you will know that the area under a standard normal curve is 1. So here, what they're asking us to do is find the area under the curve to the left of a z-score of negative 0.99. Now, the standard normal curve looks a little bit like this, where it has a mean value of 0 and a standard deviation of 1. The area under the curve to the left of a z-score of negative 0.99 would be here on the x-axis, and us trying to find the area under the curve of this. Now remember, the area under the whole curve is 1, so this will be something less than that. So let's go to Desmos, and we will type in normal dist. Now, normal distribution. Now, if I put a parenthesis here, you'll notice that it puts underneath here a mean of 0 and a standard deviation of 1. So its default settings is to use that standard normal curve. Now, we can zoom in here a little bit, and you can see that I have a nice normal curve. Let's change the y values here real quick. Let's make it negative 0.2, and then we'll make the our y value, top y value, just 0.5. 0.5. There we go. Now it looks more like a standard normal curve here. All right, so you see that I have my cumulative probability, so cumulative normal CDF, cumulative probability function, and it has some settings here. It says the region, inner, outer, left, and right. Now, most standard calculators before Desmos always calculated the cumulative distribution function from the left, and that's why I started with the first question from the left. And then finding the other values you needed to do some finagling with. Now the good news is that Desmos, with its updated cumulative distribution function, allows you to actually change it to do left, right, and then a region between two values. So here it's basically saying probability. Probability and area in this case are essentially synonymous because the probability under the standard curve is once again 1. And so since my mean is 0, my standard deviation is 1, I can essentially just type in the numbers that they give us. So since they want me to find the area to the left of a z-score of negative 0.99, I have that value right here. Now, it gives you to 3 decimal places, but if I toggle down that little triangle, it gives me it to 10 decimal places, which is more than enough. So I'm going to go to 4 decimal places for this, just because I want to use that. And let's erase all of this so that I can put my answers down here. And for A, my area will be equal to 0.1611. Okay, so B, it asked me to do the area under the curve to the right of a z-score of 1.06. Now, Desmos, if I'm going to do to the right, I have to come up and change the region to right, and then you see it, you'll notice when I change it from left to right, the x value changes. So again, in this case, because we're using the standard normal curve, I can just say that I want to have 1.06 as my z-score, and the area becomes 0.1446. And then finally, the area under the curve between these two z-scores, negative 1.5 and positive 1.25, in this case, I am going to change the region to the inner value, and then it puts x between two values. I'm going to change that lower value to the negative one, so negative 1.5 up to a positive 1.25. And you can see the visualization. This is a lot of the area, not a whole lot to the left or to the right. In fact, it brings up about 80% of that area. And so we're going to put down 0.8275. All right, next it says in a previous SAT, mean score was 1498 with standard deviation of 316. 4 test scores were chosen at random, and they give us 4 scores. So they wants us to find the z-score for each SAT score. So if you remember, the z-score formula was the value that they're looking for, and so 1920, 1240, 2200, and 1390. Those are the x values. Then you subtract the mean value, which is 1498, and then you divide by the standard deviation. So in this case, I am going to plug into Desmos. I'm going to go x1. Those are going to be the 4 values that I have to plug in, minus the 1498 all over 316. Now, I need a z-score for the 1920, a z-score for the 1240, and then a z-score for the 2200, and then a z-score for the 1390. So, since I have a formula and I have to plug in 3 times, let's make a table. That'll make these calculations go by pretty quick. So I'm just going to go to this plus symbol. I'm going to add a table. I'm going to change the y1 to that z-score formula. And so I'll go a parenthesis for the top. I'll go x1 minus. We know that the mean value was 1496. And we want to divide all of that by 316, which is the standard deviation. And so now I'm just going to type in those 4 SAT scores that they asked us to find. So 1920, 1240, 2200, and then 1390. And so we can see here are our 4 z-scores. And the way that we read that, remember, this says that 1920 will be 1.34 standard deviations away from the mean value of 1496. So let's finish this problem and put those z-scores in. So if you remember, it was for 1920, it was 1.335. For 1240, it was negative 0.816. For 2200, it was 2.222, and then for 1390, it was negative 0.342. So part B says determine if any of those scores are unusual. Well, it's only unusual if it is more than 2 standard deviations away, either positive or negative. And remember, when it's negative, the actual value is below the mean. And so there are no z-scores that are 2 standard deviations below the mean, but there is one score that is 2 standard deviations above the mean. So only 2200 is more than 2 standard deviations from the mean so 2200 is unusual. Well, that is all the Desmos examples, so we are finished. Have a great rest of your day. Goodbye.